So welcome. We are going to look at rotating around a point that is not the origin. So if we have already dilated around a point not the origin, you're going to see that this is very, very similar. All right, so first up, I have a little graph here so that I can demonstrate on the graph as well as algebraically with the numbers. Okay, so let's say that we are going to rotate, let's rotate 90 degrees clockwise around the point -3, 2. All right, so I'm going to start with, let's do 0, 3 for A. And how about 1, 5? And then we'll say C is 4, 2. All right, so 0, 3. So here's our A. Oops, I didn't mean to put that prime there. Ah! Okay, that's just our A. Just pretend. Okay, over 1, 1, 2, 3, 4, 5. All right, there's B. And then over 4 up 2. So here's C. So here is our triangle. All right, and then we are rotating around the point -3, 2. So this is our point of rotation right there. All right, so what's going to happen is basically instead of taking this and rotating it around here, we're going to take this and rotate it around here. So instead of spinning around the x or the origin, the x-axis and y-axis flipping just like that, we're going to spin it around this one. All right, but again, it's very similar to what happens when we dilate around a point that's not the origin. All right, so first thing that we're going to do, so if we want to do this algebraically speaking, then I am going to start with my point, xy, and I need to translate this over to the origin. So basically I need to subtract from this, the ordered pair, so that I can get back to the origin. So to get back to the origin would be x plus 3 and y minus 2. So if I subtract this, my point of rotation, if I subtract that point, that will bring me back to the origin. All right, so over 3 down 2 brings me back to the origin. So now I'm going to perform the rotation on this. So I'm going to rotate 90 degrees clockwise. So what that means is that when we rotate 90 degrees clockwise, that's to the right, so I'm going to switch them, and I need to make this one the opposite sign. So I'm going to end up with -x minus 3. All right, so let's just think about that. So I'm going to switch them and then change the sign on the right. So I'm going to switch this over here, so x plus 3 is going to be over here, but now I need to negate that or change its sign, so that's going to give me -x minus 3. All right, then the next thing that I need to do is add the center of rotation back so that I can, so I've moved it, I rotated it, now I have to move it back. So to move it back, I need to add this, so I get y minus 2 plus -3, if you want to think of it like that, and -x minus 3 plus 2. So in the end, our direct rule is going to be y minus 5 and -x minus 1. So this is what ends up happening when we are done from start to finish. All right, so let's take a look at what this looks like on the graph. All right, so for point A, we have 0, 3. So I'm going to do y minus 5. So if A is 0, 3, we'll write it out like this. All right, then a prime. All right, so I need to do y minus 5, which is going to bring me to negative 2. And negative x minus 1, well, in that case, it doesn't really matter. It's just going to be a minus 1. So a prime is going to be at negative 2, negative 1. So this is a prime. All right, so if we look at point B, which is at 1, 5. So y minus 5 is going to be 0. And negative x minus 1 would be negative 2. So B is going to be 0, negative 2. So here's my B prime. All right, and then C was at the point 4, 2. So when I apply the final rule, 2 minus 5 is negative 3, and negative 4 minus 1 is negative 5. So C prime, 1, 2, 3, 4, 5, is going to be right down here. So this is what I end up with. Okay, so let's just kind of zoom in, and I grabbed some patty paper here to show us what's happening. So I'm going to put this over, and this is our center right here, but I'm going to mark, this is like the X and the Y. All right, so here's our shape. So A, B, C. So C, B, and A. And it's not perfect, but it's pretty close. All right, so here's what happened. What we did was we moved this to the origin. Then I'm going to hold this down and rotate 90 degrees. And then I'm going to move my point back. So you can see I started or ended where I was supposed to. All right, but basically what happened is rather than rotating around the origin, so if we just rotated around the origin, that triangle would end up over there. But what we did instead is we're rotating 90 degrees around this point, so when I rotate 90 degrees, I end up down there. All right, now there are other ways to do this. If you want to just look at the graph, keep in mind that our general rule for rotating 90 degrees clockwise, so if we start with XY, when we rotate 90 degrees clockwise, we're going to switch them and change the sign on the right. All right? So if you look, point A is 3 over and 1 up. Okay, so if we think of 3, 1, then the opposite, if we switch them, is going to be 1, negative 3. All right, and then if you look at point B, so point B would be 1, 2, 3, 4 to the right and up 3. So this would be 4, 3. So 4 to the right, up 3. So if we switch it, we're going to go 3 and then down 4. And there we landed at B prime. So again, you can do this just by looking at the graph. If you had something like patty paper, it's very easy to draw, mark the center of rotation, and then you're just going to hold that down and spin your 90 degrees. That will show you. You can go through algebraically, or you can think of what's happening when you actually do a 90-degree rotation. And again, just act as if this is 0, 0, which is what we're doing when we move it and so forth. You can do it that way on the graph also. So just to go through and label what we did here. So first thing we're going to do from here to here is we're translating the center to the origin. So we are subtracting the center of rotation. All right, so we subtracted the center of rotation. Then here we performed, so we're going to perform the rotation. And then the last step that happens right down there is that we have to then add we need to add our center back on. So we move the center over, we perform the rotation, and now we have to move it back. So then we need to add the center of rotation. And then we end up with our simplified rule for, so let me write this, simplified rule. So this is our simplified rule for rotating 90 degrees clockwise around that specific point. Okay, again, hopefully if you have done the dilating around a point, then the rotating around a point is extremely similar. Good luck.